Okay, here is our second lesson on measuring solution concentration. The way we measure solution concentration is by the unit molarity. Molarity is in moles per liter of solution. So here is a formula you can use. Put this on your purple sheet. So anytime you see a big M, that also means moles per liter. So if I have a 1 molar sodium chloride solution, that means you have 1 mole of sodium chloride in 1 liter of solution. So if I have 1 molar NaCl, you could also write that as 1 mole per liter of sodium chloride solution. Okay, so that big M is just a representation of moles per liter. Okay. So we're going to do a few sample problems together, and then you're going to do the practice at the bottom on your own. And I will provide the answers to the first 3 down here so you can check yourself. So you're going to calculate the molarity of 9 grams of sodium chloride in a 1.5 liter solution. So I'm going, since we have to be in moles, the first thing you're going to do is convert 9 grams of sodium chloride into moles. So 1 mole of sodium chloride, and you're going to look up the molar mass of sodium chloride off of your periodic table. That is 58.45 grams. Okay. So you'll calculate the number of moles. So just divide 9 divided by 58.45 and you get 0.0154 moles of sodium chloride in that solution. If I want to know molarity, now I have to divide the moles by the liters. I'm going to take 0.154 moles divided by the volume of the solution, 1.5 liters, and you should get 0.103 molar sodium chloride solution. Make sure you put the unit and label on it. Okay. How many moles of magnesium chloride are present in 60 milliliters of a 0.1 molar magnesium chloride solution? You could do this a couple of ways. You could use the formula, or you could do this using dimensional analysis, which is my preferred method. So you're going to start with 60 milliliters. For this, molarity can actually be used as a conversion factor. So instead of looking at this as 0.100 molar, you can look at this as 0.100 moles per liter. Now that can become a conversion factor for us. And so we're going to start with 60 milliliters of magnesium chloride solution. I need to convert that into liters first. So 1 liter is 1,000 milliliters. Now I can use the molarity as a conversion factor to get to moles. For every 1 liter of magnesium chloride solution, there is 0.100 moles of magnesium chloride in that. Okay, so take 60 divided by 1,000 times 0.1, and you should get 6.00 times 10 to the negative third moles of magnesium chloride in that solution. Make sure you're pausing the video to try the problems on your own as well. Okay, now we're going to calculate the volume in milliliters of a solution required to provide 0.85 grams of acetic acid from a 0.3 molar solution. So we're going to start with the grams of acetic acid. The molarity will be our conversion factor. So 0.85 grams of acetic acid, HC2H3O2, get its molar mass. And the molar mass of acetic acid is 60.05 grams. Now, 1 mole, or sorry, not 1 mole. For every 1 liter of solution, there are 0.3 moles. Okay. But we want the volume in milliliters. So I have one more step to do. I've got to convert liters into milliliters. So for every 1 liter, there is 1,000 milliliters. Okay. So you should get 47 milliliters of acetic acid. So HC2H3O2. Okay, number 4, you're going to calculate the mass of potassium iodide in grams required for 500 milliliters of a 2.8 molar potassium iodide solution. This is very similar to problems you would work in the chemistry lab. If you were making a solution, you would have to figure out, okay, I know I need 500 milliliters, this is the molarity I need, how many grams of potassium iodide do I need to mass out to make to put into that volume of solution. So I would start with 500 milliliters of Ki solution, and I would convert that to liters first. So 1 liter is 1,000 milliliters. Now I can use the molarity as a conversion factor. For every 1 liter, there are 2.80 moles of potassium iodide. Then we're not going to measure in moles in the lab, we're going to measure in grams. For every one mole, there are 166 grams. So that's molar mass of potassium iodide. Okay, and you should get about 232 grams of potassium iodide that you would need to mass out, and then use that to make your solution. Okay, you're going to try this next 4 problems on your own. Number 4 is higher level, but it is not a harder math problem. Okay, it's a fairly easy math problem, but you do need to think through how you will solve that. Okay, so the answer number 1 you should get is 0.902 molar sodium chloride. Number 2, you should get 84 grams of potassium chloride. And then number 3, you should get 1,470 grams of potassium hydroxide. Just watch your sig figs on this. If your number's a little off, it might just be due to sig figs. And then I want you to try number 4, and we will check on that one next week.